Dear ladies and gentlemen, my name is Chris Xiao. I'm the product manager for LED general lighting at Macroblock. Today I'll introduce Macroblock's premium stage and theater lighting solution, the high-power, high-voltage, multi-channel buck driver IC MBI6673. First, I'll introduce the features and applications of MBI6673. Then I'll go through MBI6673's unique scheme, SIMO, and its benefits and advantages. Finally, the conclusion will leave you a lasting impression. What are MBI6673's features? It's based on the Single Inductor Multiple Output scheme, or SIMO in short. We will go into details later. MBI6673 is a buck controller. It accepts input from 9 volts to 55 volts with driving current up to 5 amps. You can see the 9 volts is in a special color because trucks use 9 volts as their power. This means MBI6673 has an extended application, namely aftermarket auto accessory. MBI6673 supports PWM dimming frequency up to 20 kHz. It's based on hysteretic PFM scheme, so it doesn't need external compensation circuits. MBI6673 boasts 16-bit dimming resolution. Like I said, MBI6673 is ideal for stage and theater lighting. How do the manufacturers verify the efficacy of an LED driver IC? They have 3 criteria. First, it shouldn't flicker on dimming at low grayscale. Second, it must have good dimming linearity. Third, it needs to have 16-bit dimming resolution. I'll show you how the SIMO scheme meets stage lighting customers' criteria. I referred to an extended application while talking about MBI6673 features. Its automotive aftermarket accessories, especially applications requiring dual-color dimming, such as automotive alarm light. What is SIMO scheme that MBI6673 features? SIMO scheme enables the creation of a buck control circuit with an MBI6673 buck controller, an inductor, and 4 shunt dimming control channels to dim RGBW LEDs separately. That's the SIMO scheme. How does MBI6673 meet the 3-stage lighting criteria? It doesn't flicker on dimming at low grayscale. That's because the input dimming signal is in sync with the switching frequency. Each dimming signal switches the inductor current just at the peak so it doesn't flicker. Second, MBI6673 has excellent dimming linearity. That's because the response time for dimming on time is down to 50 nanoseconds. It's the fastest available LED driver IC. As we control the LED grayscale, the inductor current going through the LED will increase proportionally. So MBI6673 has excellent dimming linearity. MBI6673 achieves 16-bit dimming resolution with shunt dimming. What's so unique about the SIMO scheme? First, let's look at the circuit diagram. When the input voltage is more than the sum of RGBW forward voltages, we can light up RGBW LEDs simultaneously. However, we cannot dim each LED separately. So we will explain it with 2 different schemes. One is the SIMO driver scheme, and the other is the separate driver scheme the industry often uses. We begin by looking at the separate driver scheme. We use 4 MBI6672s to create the scheme that dims RGBW separately. 4 MBI6672s need 4 sets of buck control circuits. Now compare it to SIMO. It only needs 1 MBI6673 and 1 set of buck control circuit to dim RGBW separately. Therefore, we know the biggest difference between SIMO and separate driver schemes is that SIMO saves customers 3 LED driver ICs. That means 3 inductors, 3 diodes, and 3 MOSFETs. Let's compare the EVB circuits directly. You can see with the SIMO driver scheme, the MBI6673 is very streamlined in terms of external circuitry and components. On the other hand, the separate driver scheme is based on 4 MBI6672s. The circuit is much more complex. It also needs a lot more external components. Now we know the outstanding benefit of SIMO scheme. It helps customers significantly cut external component counts, which directly optimizes the cost structure and drastically simplifies PCB design. Moreover, MBI6673's SIMO driver scheme has another advantage. It supports series and parallel circuits with multicolor, multi-LEDs. Let's talk about circuits with multiple serial and parallel LEDs. The first is the circuit with multiple LEDs in parallel. You can see in the image that it's a parallel LED circuit. Let's look at an actual demo showing MBI6673 with multiple LEDs in parallel. When we choose the GUI color pattern on the computer, the parallel LEDs will produce the chosen color. It's worth noting that the more LEDs are in parallel, the more driving current the system will see. The bigger the system driving current, the bigger the voltage spike that shunt dimming will produce. There are two risks associated with huge voltage spikes. One is the self-turn-on phenomenon for the LED on the adjacent channel. The other is the resulting destruction of shunt dimming MOSFET. Therefore, to effectively mitigate voltage spikes, we must put a set of snubber in parallel with each channel's shunt dimming MOSFET. This was an actual test conducted by Macroblock engineers. The current was both 2.5 amps and 5 amps. The switching frequency was between 56 kHz and 625 kHz. When we sent a 3.25 kHz dimming signal, the system performed 12-bit dimming resolution. You may ask why the resolution is reduced from 16-bit to 12-bit. It's because the snubber will worsen dimming resolution. Now let's take a look at multiple LEDs in series applications. We can see this is a circuit with multiple LEDs in series. We can see from the demo that when we choose the GUI color pattern on the computer, the multiple LEDs in series will produce the chosen color. It's worth noting that we use two 4-in-1 LEDs, so the color is very vivid and rich. Let's sum it up. MBI6673 is a buck controller with SIMO scheme. Its hysteretic PFM circuit minimizes external components, significantly saves client costs, and simplifies PCB space. MBI6673 accepts input from 9 volts to 55 volts, meaning it's good for stage lighting and automotive alarm light. MBI6673 meets 3 major stage lighting criteria. It doesn't flicker on dimming at low grayscale. It has excellent dimming linearity. It boasts 16-bit dimming resolution. MBI6673 supports multiple LEDs in series and in parallel for flexible circuit designs. Thank you for watching my MBI6673 introduction.